10.3 is going to continue with kind of the problem-solving logic puzzle part of the lesson. So, without our calculators, we may want to evaluate the values of different logs. So here's our trick, here's our strategy. We need to figure out how to rewrite these as products, which is multiplication, quotients, which is division, or powers, and that would be powers of the base, in order to do substitutions. So really what we're going to be doing, for example, in this first one, is we want to rewrite 250 as multiplication with 2, because I have the value of log of 5 of 2, and since it's log base 5, I want to see if I can rewrite this as 5, because remember, log base 5 of 5 cancels. Okay, it really becomes 1. So I want to see if I can make that happen. So that's where I'm going to head. So first of all, I'm going to think about how can I take log base 5 of 250 and rewrite it. Well, the first thing that comes to mind is that log base 5 would really be 2 times 125, because it ends in 0. Well, 125, because remember, now I have my 2-bit, 125 is 5 cubed. So now I've rewritten this in terms of 2's and 5's. And the reason I went for 2's and 5's again is because the base is 5 and I'm given this value for log base 2. Now if I apply my property of log with a product, that means that I add them. So I have log base 5 of 2 plus log base 5 of 5 cubed. Now, an exponent in a log, I have a rule for that, and so I have log base 5 of 2 plus 3 log base 5 of 5. Now, I go ahead and I substitute. Log base 5 of 2 is this decimal value. Log base 5 of 5 becomes 1, and so what I'm left with is 0.4307 by substitution plus 3, and so my value of log base 5 of 250 is 3.4305. So it's simply a matter of kind of creatively thinking about the numbers, doing a substitution, applying the rule, and doing some simple addition at the end. So now in the next one, I'm given the log base 6 of 8, I'm given the log base 6 of 32, and I want log base 6 of 4. So I have to think about how is the given information related to what I want. Well, when I look at 8, 32, and 4, I think to myself, well, 32 divided by 8 is 4. So I could write a division problem that would look something like the log base 6 of 4 is equal to the log base 6 of 32 over 8. I just rewrote 4 as a division problem. Well, once I've done a division problem, then if I apply my log rules, that means the log base 6 of 32 minus the log base 6 of 8, just applying division means subtract. Well, nifty, I know the value of log base 8, or base 6 of 8, and I know the value of log base 6 of 32, so by substitution, put this one in first, 1.9343 minus this one is equal to that, 1.1606, then that means that the log base 6 of 4 is equal to 0.7737. If I look at this last example, I have to think about log base 5 of 6 I'm given. So is there any way to rewrite 216 in terms of 6? Can I write it as a product, as a quotient, as a power? And if I remember to myself, if I think about it, 216, if I check my table, is 6 cubed. So I can say log base 5 of 216 is equal to log base 5 of 6 cubed. I haven't changed my numerical value. I just rewrote 216 in a different form. Now I'm going to apply my exponent rule, and I'm going to say 3 log base 5 of 6. I know what the log base 5 of 6 is, so I can replace this. So I have 3 times 1.1133, simple multiplication. And that's how you evaluate logs for certain values that would not be possible to do on your calculator. You cannot do log base 5, base 2, base 7 on your calculator. This is the only method. So that is the end of the 10.3 lesson.